All right, so we're at FabTech at the FANUC booth, and here I have Devon with us, who's going to explain the seam tracking, the 3D vision that FANUC has. So thank you for joining us, Devon. If you wouldn't mind, go ahead and start off by giving like a brief introduction of yourself.
Okay. My name is Devon Ritchie. I'm a materials joining segment engineer for FANUC, and here we are at FabTech.
Awesome. So what about the seam tracking is so good?
So this actually scans the part, and it can adjust the torch to the variable parts. So if you have a helix here, is not always going to be the same when you put it on the core pipe. So this seam tracker is going to find that edge as it's welding and adjust where it needs to be to keep on that edge.
Very good. So essentially, like whenever these two pieces of metal are tack welded and they don't line up perfectly, it can do some adjustment there to accommodate for that gap?
Yes, absolutely.
Very good. So this offers like a lot of flexibility in being able to deploy like different sizes of these, because that way you can teach it one time and then it can operate the weld on that new part.
Yes.
Awesome. And for the 3D vision, what is the 3D vision doing?
The 3D vision is going to scan the area and pick the part that you want to pick. And then if there's any variable in it, someone bumps the rack, the robot will adjust and grab in the proper orientation to present it.
Yeah, so that's one thing that's really nice about like 3D vision. One, it is just overall a better vision system than 2D, so you can use the 3D vision system for 2D type of applications and just get better results out of it. But the other thing that you gain is your yaw, pitch, and roll, which is, like you said, if it gets knocked over and it's tilted, that means the head of the robot will then shift and be able to accommodate for that hit part.
Yes. So we also have through-arc seam tracking, which is also a variable welding process that has a weave, which you can see right now. It's measuring the amperage provided by the power supply, and we're measuring and watching what that amperage is so that it can adjust in either direction to keep the weld in the seam.
Very nice, very nice. So that just overall helps like get a better consistent weld.
Yes.
How quick is this deployable to, like, let's say for it's a new part after it's been set up?
Right now.
Right now.
Right now. All you have to do is set up all your variables and run it.
Very good. And for that variable setting up process, how long do you think that generally takes?
Just a couple minutes. You want to tell it what's your wait time, what amperage you're looking for, and it's going to follow that process.
Got you. And for telling the robot let's say the size of the part, let's say first we went with a longer part this time, what all do you have to do to accommodate for that?
All you're doing is changing your length of your weld. The process is going to stay the same. So once you set that up, you just want to say you're running your through-arc seam tracking, and then it's going to run as long as your weld is.
Okay. And is this set up like through like a wizard or like?
Nope, it's all on our software. All on the teach pendant.
Awesome. Awesome. So as you can see, guys, like this is like something that's super easily deployed. As you can see, guys, this is something that's like super easily deployed, and after it gets set up by like an integrator such as ourselves, you can run this thing and run it to new parts that are in your process with a very minimal change and very minimal time to implement the new part into your system. Awesome. All right. Well, thank you for joining us today.
Thank you.
Thank you for giving us the information. Catch you in the next one.